Hi guys, in this tutorial I'm going to solve question number 5, Mechanics 1 Jan 2021 Edison. A particle is acted by two forces, F and G. The force F has magnitude 8 and act in direction with bearing 240. The force G has magnitude 10 and act due south. Given that R is equal to F and G, find the magnitude of R and find its direction. We'll show the direction of each force first. Let's say the particle at this point. The first force, which is F with bearing 240, started from the north direction. So 90 plus 90 plus 60 to get 240. This is the direction of the first force, which is 8 Newton. The second force is 10, act south. So this is the direction of the second force, which is 10 Newton. To get resultant of two forces and the angle in between given, the first method you can apply parallelogram method. How? This force will be like this, and force 10 will be like this. So now we have parallelogram. So the length of diagonal represents the resultant. This is the resultant force. You can find the measure of this angle will be 120 degrees. Co-interior angle, their sum is equal to 180. This side, as its magnitude 8 and 10, we have two sides and angle included, so you can apply cosine rule to get the magnitude of R. R squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times cosine 120. This is the magnitude. After getting the magnitude, you can apply sine rule to get the direction. First, find exact value of R, 10 squared plus 8 squared minus 2 times 10 times 8 times cosine 120. So the answer will be 244. By taking the square root, so R exact is 2 root of 61 and rounded to be 15.6 Newton. This is the magnitude of R, which is in part 1. You can find the direction by finding the measure of this angle. You can apply sine rule, which is 8 over sine alpha is equal to R found 2 root of 61 divided by sine 120. You can find alpha. Sine alpha is equal to 8 multiplied by sine 120 divided by 2 root of 61. And you can find the measure of angle 8 times sine 120 divided by 2 root of 61. So equal, shift sign to get the measure of angle alpha, which is 26 to the nearest whole number or to the nearest degree, but he asked to get the bearing, so you can find the measure of this angle to show the direction. So in part 2, direction of R giving your answer as a bearing. So 180 plus 26. So the answer will be 206. This is direction of R. Let me repeat this question again, but by using a resolving method, because we have two forces. and we can use this method for more than 2 forces. I will show it again, the direction of the forces. We have 2 forces. The first force makes bearing 240 degrees. So you can show this angle 60 degrees or this angle to be 30. You can use it to resolve. This force is 8. By using a resolving method, whatever 60 or 30, if we use 30, will be 8 cosine 30 and 8 sine 30. For the second force, which is 10 in this direction, also we can resolve it. It's already 10 Newton in this direction. Now you can find f of x and you can find f of y. F of x, because it's a left-hand side negative direction, so negative 8 cosine 30 to show the direction, but its magnitude is 8 cosine 30, and f of y, which is negative 10, negative 8 sine 30. To get the magnitude, r is square root of f of x squared and f of y squared. To get the exact value of r, which is square root of 8 cosine 30, whatever negative all squared, you will get it positive, plus negative 10 minus 8 sine 30 all squared. You will get the same answer found by the first method, which is 2 root 61, 2 root 61, or as a decimal 15.6. 15.6. To get the direction of the resultant, say the resultant will be in between like this. This is direction of resultant. You can find the measure of this angle by using shift tan, tan minus 1 y over x. So will be tan minus 1 y value, which is this value, as a magnitude will be 10 plus 8 sine 30 divided by 8 cosine 30. But after finding this angle, you can find the bearing. Shift tan, 10 plus 8 sine 30 divided by 8 cosine 30 equals, you will get it exact as 64 rounded degrees, but the bearing will be 270 minus 64. So the answer will be 260 degrees bearing. Same answer found by the first method. Thank you.